So this is the Edexcel IGCSE Further Maths paper 2. It's also calculator, which paper 1 was as well, which means that it loses any and all credibility it had as an actual maths paper. The fact that you would write 2 papers and you would make them both calculator is ridiculous to me, and everyone who works at Edexcel should take a very long, hard look at themselves. Anyway, it's from paper 9. It's from 2019. Let's get straight into it. So vectors questions to start with. We've got a point A with this position vector. I always find it helpful to draw these things. It only takes me 2 seconds. So I'm just going to draw them both. This is A, this is B, and I'm trying to go from A to B. So I'm doing this. Well, clearly I have to go -3 across and then 4 up. So the vector in terms of I and j is -3i plus 4j. A unit vector that's parallel to that, so it needs to be a multiple of this, but needs to only have length 1. Okay, well, what length does this have? Well, it has length 3 squared plus 4 squared, which is rooted, and then 5, which is 5. Obviously 3, 4, 5 triangle. So this has length 5, so if I just divide it by 5, I'll get something with length 1. So that would be a vector that's parallel and has length 1. Good. Number 2, this is a very classic A-level further maths question, this. Really interesting. Oil is leaking from a pipe and forms a circular pool, horizontal surface. The area of this thing is constantly decreasing here. Okay, so we've got a pool that's in a circle. So the surface area of that circle is clearly pi r squared. So surface area, I could have called it A, I guess, but S for surface area is pi r squared, where r is the radius because it's a circle. And we know that S is increasing at a rate of 8. So ds by dt, the rate of increase of S is 8, is what that says. And now it says find the rate at which the radius of the pool is increasing. So we do a bunch of things to this. If you've done a couple of questions like this before, you sort of know what to do, I think. Essentially, you just say, well, okay, this here tells me ds by dr is 2 pi r, just differentiating. Cool. And then what I can do is I can say, well, dr by dt, which is what I want. I want the rate at which the radius is increasing, so that's dr by dt. That's going to be ds by dt times dr by ds, because like these ds's will cancel if you pretend these are fractions, and you just end up with dr by dt. Well, ds by dt I know, that's 8. Dr by ds I don't, but if I flip this over I sure as hell do. So that goes in there, and then I put it in here. 8 times this is that, and then it says when the area of the pool is 50. Well, when the area of the pool is 50, that means S is 50. Solve that for r, just divide by pi and square root, and then put that r into there, and you get dr by dt is 0.319 to 3 sig figs. So this trick here of turning one of them upside down and then doing this is called chain rule. Yeah, if you've done a couple of questions that look a bit like this before, then yeah, it's just the same thing every time. Question 3, so acceleration is the rate of change of velocity, so that's dv by dt. So dv by dt, I can just differentiate this to get this, and then when t is 3, just put t as 3 in, and you get 2. 2 times 3 is 6, minus 4 is 2. Find the distance that the thing travels. Now the distance is the integral of velocity. I always think of it as a ladder that goes displacement, velocity, acceleration, going down to differentiate, up to integrate. So we integrate this, and we get this. Now there's a plus c on the end of this, but we can just sort of pretend that at time 0 the distance is gone as 0, which kind of makes sense anyway. But even if you didn't, you could say the distance is 10, but then when you work out what the distance is, it's after 6 seconds, you would just take away 10 again, so it kind of cancels out. So you can just say it's 0. Just put 6 into here, and you get a distance of 42. Just type this into a calculator. It's a calculator forever, just type it in. Question 4, so yeah, I have seen this question at the very end of a GCSE exam before. You draw what they're telling you to draw, triangle ABC with these lengths, and you want the value of x, which is yeah, the x in here. You've got the angle ABC, which is this one here is 60. This is where this could have been a non-calc paper, right? Because if you don't know what cos 60 is, you're a pleb. It's a half. Half times 2 cancels out, so we just end up with this cancelling. Again, if you don't know what 5x all squared is, you're also a loser. It's 25x squared. Then we square all these things out. You just tidy up everything very carefully. I divided this by 3 in the hope that it would factorize, and it didn't. So you just get out the quadratic formula, type it straight into a calculator, and you get these 2 answers. Of course, this one implies that this length is negative, which cannot work. So this goes away, and we get this as our only answer. Excellent. Just be careful with the negatives over here. I think I messed that up initially, if I recall correctly. Cool. Question number 5. Quite a fun question here. This is one of those questions where, like, I think lots of us can do this question, but what is the most efficient way you can find to do it, and what's the way that you have most fun doing it? And for me, if xy is 36, just make this 36, right? That's just what it says here. Just make that 36. Take away 36 on both sides. And now, okay, I've got this new equation which has x and y in it, which doesn't seem very helpful at first, but now I'm just going to times everything by x. And the reason I'm going to do that is because that means I can just shove in another copy of xy into here. And then if I rearrange, I end up with something that just has x's in it. Most people, I think, would just divide both sides here by x or y and then put it into here and then multiply some stuff out. But I think this is quite a nice little way of doing it. Of course, this factorizes just to x minus 9, x minus 8. So this has solutions x is 8 and x is 9. Put those into here. If x is 9, clearly y is 4. If x is 8, it's 4.5. And those are our two answers. 6, so this is a bit of product rule. So what product rule says, if you're differentiating something which has got one thing multiplied by another thing, you differentiate this thing first and leave this thing alone, then you add on, leaving this thing alone, differential of that thing multiplied. This is the answer here. You differentiate this thing, which is just 4, and then you tag this thing on, just leaving it alone. You've just tagged it on. And then you add this thing left alone, and then you differentiate this thing, which is just 2e to the 2x, and that will be my answer. And that's the whole thing. That's literally the all 3 marks. You don't have to simplify because it doesn't say to. Show this thing. Now, I had a real mess doing this. There's got to be an easy way to do this that I just haven't seen. I brought the 2 out to here, clearly. Then I said, well, this thing here is y. Like, that thing there is just exactly what they've defined y to be. So that's cool. I'll put that in there. And then I said, well, what I'm thinking about is this. So let's just times both sides by 4x minus 3. So times this by 4x minus 3 times this by 4x minus 3. Okay, now I can put this 4 at the front again, just because all these things are multiplying, so I can just move it to the front. This I can expand out if I want to. But again, here, this is an exact copy of y. Just like I said before, it's just what y is. So this is 4y. And of course, this simplifies to this, which factorizes to this, and now I've shown what they wanted me to show. I mean, it's weird. I got 3 marks for just doing one line here, and then 2 marks for doing like 7. There must be an easier way to do that I'm just too stupid to see, and yeah, I don't know. Anyway, I couldn't be bothered to think about it anymore. Part B, differentiate this. Now, you could use quotient rule here, and quotient rule is actually given in the formula sheet at the front of this exam. I never use quotient rule because I hate it, and I can't remember it anyway. I just always make whatever's on the bottom into a negative power and then do product rule. So again, product rule is when you differentiate this one and leave this one alone, and then you add on differentiating this one, leave this one alone. So this one differentiated is cos 5x, sorry, is 5 cos 5x. Sine differentiates straight to cos. The 5 brings out to the front. Leave this one alone, and then you add on this one left alone, and then you differentiate this. So the 2 comes down for a minus 2 times the differential of this, which is just 1, and then this with the 1 taken away from it here is a minus 3. It doesn't even say to simplify, so I think that's 3 marks. I mean, it would be more usual to leave it a bit like this. You could even do some factorizing if you wanted to, but this would give you the full marks, I'm sure. Question 7 about series and summations. If you want to, if you don't know immediately how to recognize this, you can just write a few of these out. When r is 1, you get 4 times 1 plus 5, which is 9. And then when r is 2, you get 4 times 2, which is 8, plus 5 is 13, and so on. So this is what this is asking you to do up to the nth term. So the first term is clearly 9, and the difference is 4. So that's good. You can do the same here if you want to. Just put in r is 1, which gives you 3 to the power 0, which is 1 times 4 is 4. R is 2, gives you 3 to the power 1, which is 3 times 4 is 12, and so on. So the first term is 4. And the common ratio, or each of these, is timesing by 3. So okay. Find the value for which this thing is true. So a to the 14 is when you stop at n is 14. So you say n is 14 and you get to the 14th number here, which involves putting 14 into here and then adding up all the other ones. So it looks a bit like this, right? That should definitely be a 14. Massive apologies. Right there, that should say 1, 4, not just 4. I'm putting in n is 14, so the last time we'll have a 14 there. I hope I've made that clear by saying it literally 5 times in the last 10 seconds. So anyway, that's going to be the sum of this, and then we take away 6, and that's going to equal g of n to some n, which this time we don't know. Now, you could add these up if you want to, but don't. Again, in the formula book that I mentioned earlier, you get this formula, which is how to work out the sum of an arithmetic series, where n is the number of terms, which in our case is 14, not 4. A is 9, because we've already said that, and d is the difference, which is 4. So we can just put that into the formula, and again, just get a calculator and type this in, and you get 490, which means this thing is 490. I've called it S of 14, maybe I should call it A of 14, who cares? This is 490, take away 6 is 484, and that's equal to this. Now also at the front page of the formula booklet is how to sum up a geometric sequence. It's this to n terms, where again A is the first term, R is the ratio, and n is the number of terms. Now the number of terms is the thing I'm trying to find out, but I know it equals 484. So 484 equals this with a 4 here and a 3 here. Because of these numbers here. I can solve this. This makes minus 2 on the bottom, so just times everything by minus 2, and you end up with this. Divide everything by 4, add 242, add 3 to the power n, and then you can do log to base 3 of both sides if you want to here, or just recognize that when n is 5, this is what happens here. So n is 5 will be our final answer. Apologies for the mistake on that slide. Question number 8. So again, let's draw this. As soon as we see coordinates, just spend 2 seconds drawing it. It's not hard. So we get these coordinates here, A, B, and C. Find the distance between all the points. Okay, so we just need to do Pythagoras, right? The distance across is 4, up is 2, so this is going to be 4 squared plus 2 squared square rooted, which simplified is 2 root 5. Your calculator will do that for you, of course. B to C, that's 2 across 6 up, so that's 2 squared plus 6 squared square rooted, which is 2 root 10, and then A to C just likewise. What we notice immediately, and this is what you want to kind of stay on top of when you're doing these kind of questions, is 2 of these lengths are the same. So that if you draw a triangle, which is what you're about to do, it's isosceles. And you want to be thinking that as soon as you see things like this. Now, work out the size of each angle. There's lots of ways you could do this. Immediately, what you might think is to do cosine rule. Just get this one, find this angle first, and then do some cosine rule here, find cos of A. That's fine if you want to do that. What you might have noticed is the reason that I want to do this angle first is because, again, this is isosceles. So if I have this angle, I just need to do 180, take away this one divided by 2. And then I save myself doing any other trig. Actually, the easiest way to do this, though, which I spotted as I was typing this, was 2 root 10 is actually 2 root 5 root 2, which makes this side here just root 2 lots of this side. And my favorite triangle is the 1, 1 root 2 triangle, by far my favorite triangle. It's got a right angle here, and it's, of course, isosceles, so 45 and 45. But of course, if this is just a scale factored version of this, this is just this triangle times by 2 root 5, can we agree? Times by 2 root 5, times by 2 root 5, times by 2 root 5. So these angles here must just be 90, 45, 45, because they're similar. They're similar shapes. So I saved myself doing a bit of cosine rule there. Those are going to be the angles. Now, the points A, B, and C lie on a circle with center P. So there's some circle going around here with center P. With these 3 points. Now the thing is though, if you've got a triangle in here and you make a 90-degree angle on the circumference, that means that the line opposite that 90-degree angle must have been the diameter of the circle. So it's not going to look like it when I draw a triangle in here. This doesn't look like the diameter. But because this is a 90-degree angle, which I've already said that it is, this must be the diameter. And so if P is the center of the circle, and BC is the diameter, then P is just the midpoint of the points BC. So clearly the coordinate 5, 5. Okay. So I can just use the midpoint of BC there. Find the exact length of the radius. Well, okay, but BC is the diameter, as I've said, and BC has length 2 root 10. Now the radius is just half of that, so the radius is going to be half of this, which is just root 10. So I'm not sure what my 2 marks were there for. But anyway, question number 9. So we've got a function, passes through these points. The differential of the function is this. So if I integrate this, I should get my f of x. So I've just integrated this there. Plus c, of course, when you integrate. But I know it goes through this point. So I can put in x is minus 2, y, which is equal to f of x, is equal to this. So just put those 2 values in, type all of this into a calculator in one go very carefully, and you get this. Of course, these cancel out and you get c as 0, which means the function is just this, because plus 0 I don't need to write. But of course, because the y-intercept is 0, it goes through the origin. Or you can say, when I put in 0, I get 0. It doesn't really matter. But yeah, y-intercept is 0, that's my 4 marks. Show that FC has a minimum point at this. Now I don't need to differentiate because I already have the differential. So I just need to ask, when is this 0? When is this thing 0? Now this is a cubic, and I don't like solving cubics, but it's actually helped me out quite a lot. It said that show that it has a minimum at 2 and at 1. Now if you're solving cubics, one way to do it is to use factor theorem and just guess some things that might work. But of course, if they're telling you the values, I would suggest just guessing them. F of 1 is clearly 0, and f of 2 is also 0. So 1 and 2 are stationary points. By factor theorem, if you put it, well, that's not even factor theorem, is it? No, it's not. I'm just saying when you put in 1, you get 0. So this is a solution, obviously. Okay, so what type of stationary point are they, though? Well, I need to differentiate that again to find that out. So if I differentiate again, I get this. And now I put in x is 1, and I get this, which is less than 0, so that's a maximum. And then I put in x is 2, and I get this, and that's more than 0, so that's a minimum. So okay, that's all 7 marks. Oh no, it's not. Find the exact value of the y coordinates. So there's my function. X is 1. Just put that into the original function to find the y coordinate, not the differential or anything. To find the y coordinate, just put it in the original function. So put in 1 to there, put it into a calculator, and you get this. Put in 2, put it into a calculator, and you get that. So my coordinates are 1, 23/12, 2, 4/3. Maybe I should have written that out more carefully. But anyway, the curve has another turning point A. This is where I'm going to use factor theorem. I'm going to say, if this thing is true here, f dashed of 1 is 0, that means x minus 1 is a factor. And also x minus 2 is a factor by factor theorem. So this function here breaks down into x minus 1, x minus 2 times something. Now clearly to make an x cubed, I'm going to have to make an x here. That's just going to have to be a regular x. And to make a plus 4, well currently these things multiply to 2, so I just need another plus 2, which means the final solution is at minus 2. And you can check that if you want to. You can put in minus 2. You could have also just tried more values in here until you found one that worked. But f of minus 2 is 0, so that's the last stationary point. In the nature, put minus 2 into the second derivative. I found the... of course, it asks you for the coordinates of A. So it happens at x is minus 2. Now x is minus 2, they've already told you what y is at that point, so that's quite cool. Y is just that. Now to find the nature of it, then I put minus 2 into here, and you get a positive number, and so therefore it's another minimum. And this will be the entire question. Good. Question number 10, the roots of this are alpha and beta. Without solving the equation, do some stuff. I'm just going to cut some of the question out here because I'm going to need some space. Now, when you're looking at a polynomial, the sum of the roots is this number over this number with a negative, so minus 3 over 1. And the product of the roots is this number over this number, but positive. But because minus 5 is minus 5, that just makes a negative anyway. So we get these two statements here. Cool. Without solving these equations, do this thing. Now, to do this, again, if you practice this kind of question, it's always the same thing. You square all of this, a plus square both sides, negative 3 squared is of course 9, this squared, expand brackets carefully, you got this, but alpha beta I already know. This is a bit like that earlier question I did. I'll put the alpha beta in here to get a minus 10, add 10 to both sides, and I get alpha squared plus beta squared is 19. To find alpha to the 4 plus beta to the 4, we get out this meme, and we literally do that. So we square both sides. This makes, when we expand out these brackets, this. But of course, if alpha beta is minus 5, if I square both sides, I get alpha squared beta squared is 25. So put the 25 into here, and then we take away 50, and we get our answer there. Good. Next part of the question. If alpha is bigger than beta, show this thing here. Okay, so we're going to be using some of the stuff that we can see up here, hopefully. So alpha minus beta. Consider what alpha minus beta squared is. Because we can see a root 29 here, so clearly some rooting happened. Consider alpha minus beta squared. If we square it out, we get this. But of course, if I just put the beta squared there, because it doesn't matter what order I add in, alpha squared plus beta squared, sorry, is 19, and alpha beta is minus 5, so we get 19 plus 10, which is 29. But of course, that means if we root both sides, we get alpha minus beta is 29. Now, there's no plus minus here because it's told you that alpha is bigger, so this isn't a negative thing. Alpha is the bigger one, so this is positive, so this is positive. And it might have been weird as to think, how did I know to do this? Well, it's just because I've done questions like this before, and you generally do this, so I just did it. Okay, factorize this completely. Now this is actually a difference of two squares. It's alpha squared minus beta squared, right? So this is a difference of two squares, which means when I factorize it, it's this minus this times this plus this, right? So we make this. But of course, get out the meme again. This is also a difference of two squares. Right? Much more recognizable one, it's just alpha minus beta, alpha plus beta. So we end up with all this. But of course, hence find the exact value. I know what all of these things are. I know alpha minus beta is this, I know alpha plus beta is this, and I know alpha squared plus beta squared is that. So I can just put those in, times them together, and I make this here. Final part of the question, given beta to the power 4 is this, find the value of p and q. Now I actually have two equations that are helpful here with beta to the power 4. I have this one here, alpha to the 4 plus beta to the 4 is 311, and I also have, I haven't really written it down, but alpha to the 4 minus beta to the 4 is all of this. That was the last bit of the question there. So I also have this. Now, of course, if I don't want to add these together because that will cancel the betas, I want to take them away. If I do this, take away this, minus minus makes a plus, these cancel, and then I get this here. And of course, I can divide by 2, and I end up with this, which makes p 311 over 2 and q 57 over 2. And that is that. Final question then. This is a lovely question. Yeah, this is just lovely. You should show this to all of your friends, maybe down in the library or wherever it is that you hang out, because it is just great. You've got a pyramid here. AVC is 90 degrees, so it's got like a right-angled top up here. It's a square-based pyramid, so these sides are 16. That, of course, means that I'm trying to work out the height, but the distance all the way across. Again, getting out my favorite 1, 1, root 2 triangle, which I was hoping would come out here. Oh well. Thinking about the 1, 1, root 2 triangle, or just doing some Pythagoras, you can find this distance is 16 root 2. Now that makes this distance here, because this is going to be symmetrical, because it's square-based, that makes this distance here 8 root 2. But if this is a right angle up here, then when I break it down straight down like this, that makes this 45 degrees. Now this is also a right angle, of course, and that makes this 45 degrees, so this triangle is isosceles. So this length here, the height, is just going to be 8 root 2. I use this triangle, which maybe should have come up earlier, but this is just, this base here is 16, 16, 16 root 2. It's just this triangle times by 16. So you save yourself from doing Pythagoras if you just have this triangle in your head. Anyway, final length of VA, so that's this distance along here. Well, that's the same as distance along here, of course. So that's going to be 8 root 2 squared plus 8 root 2 squared square rooted. But again, I don't need to do that because that's just this triangle times by 8 root 2. So this length is going to be 8 root 2 times root 2. Again, just thinking about similar triangles. Root 2 times root 2 is 2, so that makes this 16. Good, so saved myself quite a lot of work, not really done much for 7 marks. Final length of D to VA perpendicular. So D to VA such that I make a right angle when I meet it. Okay, now this one seems a bit weirder, but what you notice is that, okay, this is 16, but also this diagonal is 16. So all of these triangles are actually isosceles. Sorry, not isosceles, well, technically isosceles. They're equilateral. They all have, all three sides 16. So if I'm trying to work out the distance from one corner out to the perpendicular of the other length, that makes a right angle here. And this shouldn't have all come up at once, but anyway, this length is going to be 8. Just half of the 16, and then I can do 16 squared minus 8 squared equals 8 squared, square rooted, and that makes 8 root 3 exactly. Okay, so find in degrees the size of the angle between VAB, so the plane VAB, and the floor. So I'm looking for kind of the angle that goes from this curved face, or not curved face, but slanted face, down to the floor. Now, always think about making triangles. I've got a height here of 8 root 2. I've got a length across here I can work out is just 8, because it's just half of 16. And I'm looking for this angle here. So this is going to be a right angled triangle, height 8 root 2, width 8. And I can just do tan here, right? Tan of x is this over that. 8's cancel, so it's tan inverse of 2, which is 57.4 degrees. And that would be that angle there. The angle between the plane VAB, now that's the plane going back into the background there, and the plane VAD. So I've got the angle between two planes now. So it's kind of like an angle that joins the two slanted faces up here. Now, I had to do a little bit of thinking here until I realized, okay, well, firstly, get rid of all of this clutter. They've helped you out a lot by asking you to work out D to VA, the perpendicular. That was 8 root 3, remember. And that also means, just by symmetry, that this length, which is doing exactly the same thing, just going from the opposite corner out to the other end of the face, that's also 8 root 3. Now, I've also worked out the diagonal base is 16 root 2. So I have a triangle here that looks like this when we look at it kind of from straight down into it. And I'm trying to work out this angle here, of course, the angle between this plane going back into the background of the picture and this plane at the front. So this angle here is what I'm trying to work out. But of course I can just do some cosine rule here. Lots of things start cancelling because of all the square roots. You can type this into calculators if you want to, because it's a calculated paper. I would suggest that you practice doing this properly by hand, because it's very helpful too. But anyway, when you get all this done and do cos inverse, you get this answer here, which is going to be the final answer of the paper. So yeah, thank you very much for watching.